Hi, my name is Vaibhav. I am a PhD scholar at IIT Madras, and this is an online live session for physico-chemical processes for wastewater treatment. So, this is week one live session, and the lecture outline will be environment and pollutant. What are these things? Pollution discharging industries sectors, treatment, why, how much, types, environment acts and standards, monitoring of water quality, constituents of concern in water or wastewater, and at the last we will study about water quality parameters. So now, uh, what is environment and what are the pollutants? So environment is which includes air, water, and land, and the interrelationship which exists among and between water, air, and land and human beings, other living creatures, plant and microorganisms, and property. So this is environment, the interaction, the place where we interact uh, on Earth. That is environment, and their interrelationship also exists in that. And what is pollutant then? So any solid, liquid, and gaseous substance present in the environment in such a concentration which can be injurious to human health, environment, and property. So this is called a pollutant. But the thing is that a pollutant can exist in a place. So a pollutant is called pollutant when it crosses a certain limit, crosses a certain concentration, and it stays there for a duration, and for a particular time it stays. Like for noise as a pollutant, suppose daytime a sound wave may not be a pollutant, but at night time it can be a pollutant. And at a certain place also, suppose ozone is there, ozone in troposphere is not a pollutant. Oh, sorry, ozone in troposphere is a pollutant, but in stratosphere, not a pollutant. Hi, Sharvia, are you there? Hello, Sharvia?
Hello, sir.
Yes, I'm asking, can you hear me?
Yes, sir, I can hear you. Tell me,
Okay,
sir.
okay, okay. So I think you joined few minutes late, I guess.
Yes, sir, I had
Oh,
some work, so I
oh,
just joined now.
no issue actually. I was expecting some people, but here no one is present. So, okay, I will start again, no issue. Oh,
It's okay, sir. You can continue, sir. It's
okay,
okay.
okay, okay,
Yeah.
okay.
Thank you,
So,
sir.
yeah, I will introduce again. Okay, here is my PPT. Can you see that?
Sir, I can see.
Okay, okay. So the thing is, this is a first live session. I'm also my first live session on physicochemical processes for wastewater treatment. So my name is Vaibhav. I am PhD scholar at IIT Madras. Uh, so this will be the course outline for this lecture. Environment and pollution, pollution discharging industries, treatment, why do we do, how much, and what are the types of treatment, environment acts and standards, monitoring of water quality, and all constituents, and water quality parameters. So, what is environment and what is pollutant? So, the environment is where we interact, that is environment, and pollutant is any solid, liquid, or gaseous substance which is present in the environment at such a concentration that is injurious to health, environment, or property. So, that is called a pollutant. And here I am defining like why it is a pollutant, means how it is called a pollutant. Like when it crosses a certain concentration, then we call it as a pollutant. And if it stays there for a limited duration, then it is called a pollutant. And it depends on the time also, at what time the pollutant is present. Suppose noise in night time can be a pollutant, but daytime it is not a pollutant. So that's why that's how we are defining. And at place also, suppose in troposphere the ozone is present, then it is a pollutant. But in stratosphere we have ozone layer, so there it is not a pollutant. Now we'll go to next. So there are some industries which discharge the pollutants. So the industries are actually mentioned here: sugar, cement, paper and pulp, dye industry, oil refinery, distilleries, iron and steel, thermal power plants, and many more. So likewise, we have many industries which operate and they produce water, or sorry, wastewater. So uh, they cause some pollution if they are discharged into the river, lakes, or any water body. So let me check how many people have joined till now. Hi everyone, can you hear me? Hello, Aral, Deepam. Okay, I will be continuing. So now we will see why treatment, how much to treat. So why treatment is required? If you can hear me, can you tell why treatment is required? Hi Devika, can you hear me? Can anyone tell why treatment is required? Why treatment is required and how much to treat? Can anyone tell? You can write in the chat box also. Okay, I will tell why treatment is required. So as we discussed about the pollutant, what will it cause? It will cause pollution. And due to pollution, we can't use the water. Means if water is polluted, we cannot use that water, so we have to treat it. And we will treat based on the intended use. Means we will decide first that for what purpose we are treating the wastewater or water. So suppose if we are treating the wastewater for agriculture, and suppose we are treating the wastewater for drinking purpose, so both treatment should be different and will be different. So for drinking water, we may require good quality of water comparatively, and for agriculture we may not require that good quality of water for agriculture or for gardening, for any other purpose. So first we need to know what is the intended use of the water or wastewater. And how much to treat will depend on existing water quality and required water quality. So the difference between these two will give us how much treatment is required. How much treatment to be done. So this is about treatment, why we need treatment and how much treatment. And we will also understand about type of the treatment. So we studied about this why and how much. So there are basically three types of water or wastewater treatment. So in physical treatment, what we do, like we do filtration and settling. Filtration you might have seen, earlier when ROs when RO UV filters were when RO and UV these treatment units were not there. We used to have filtration unit. So physically it used to treat the water, and we have seen in the river also. Uh, it is a natural phenomena when suspended solids are present in river, they will settle at the bottom. So water can be treated using physical treatment also. And we can see for chemical treatment we had chlorine and ozone, or some other chemicals which we study in future, like coagulation, flocculation and all. So these are actually chemical treatment. And for this biological treatment, we have seen, like in our households earlier, there used to be septic tank. So it is a biological treatment unit. So in this subject, we will study only these two physico-chemical processes. So we will not study biological treatment. So that in this course, we will be studying physico-chemical treatment. So these are the types of treatment. Now, before treatment, we need to know what are the acts and standards. So based on the requirement, we will treat the wastewater. So the objective of acts and standard, and the objective is to provide protection and improvement to the environment. This is a generalized definition, and specifically for our uh, specifically for our this course, which is based on wastewater treatment. So we our objective is prevention and control of water pollution. So this is our objective. And like for drinking water, our standard is, can anyone tell what is drinking water standard IS code number? You can write in the chat box also. Can anyone tell what is the drinking water standard used in India? Okay, it is IS 10500, I think 2012. So this is the drinking water standard used in India. So likewise, this is for drinking water. Likewise, we have discharge standards for discharging the industrial effluents into the water body, and those water body can be sea, river, lake, and any other thing. So let's discuss about duties of Indian citizen as per the. So duties of Indian citizen are defined in Constitution of India. So like we have rights, we have fundamental duties also. Actually, we have 11 fundamental duties. So out of 11 fundamental duties, uh, there is one fundamental duty is to protect and improve the natural environment, including forests, lakes, rivers, and wildlife, and to have compassion for living creatures. So, it is our duty to protect and improve the natural environment. So that's why it's very good thing that by studying and understanding this subject, we are completing one duty. So there are general standards for discharge of environment pollutants. So these are actually means after the treatment, the pollutant load should be that much. This 100, 600, and 200. Let me explain it further. Suppose uh, like there is a there are different water bodies: inland water, public sewer, land for irrigation, and marine coastal areas. So if you want to discharge any water, that water should have 100 milligram per liter of suspended solids, and in uh, for the inland water, and for the public sewer it can have 600 milligram per liter, and land for irrigation it can have 200 milligram per liter. And likewise we have some standards for marine and coastal area. So this is after treatment we can have this much limits. And uh, it doesn't depend on the type of industry. Likewise we have wastewater generation standards. So in the last slide we studied about the concentration of the pollutant. The unit was milligram per liter, means it is based on the per liter. The quantity depends on per liter of water. So but here in wastewater generation standards, so it tells the quantity of wastewater to be discharged by a particular industry. So suppose sugar, and I have taken an example of sugar industry. So it can produce zero point 0.4 meter cube per ton of cane crust. So it will tell that for 1 ton of cane crust, that much amount of wastewater we can produce or discharge. But after that also we need to treat that. It tells about the quantity. It doesn't tell about the quality of wastewater discharge. So this is second thing. Third is load based standards. So it tells the load to be discharged by a particular industry. So load means the load here is defined as oil and grease, BOD, COD, like this is the load. So uh, the first one was telling about the constituents like suspended solids and all. Second thing was telling about the wastewater generation in quantity. Third one is telling about the for an industry how much these constituents can be discharged by a particular industry. So that load is defined. So like for petroleum oil industry, oil refinery, oil and grease can be 2 kg per 1000 tons of crude processed, and BOD is 3 day at 27 degrees Celsius should be 6 kg per 1000 tons of crude processed. COD should be 50 kg per 1000 tons of crude processed. So these are load based standards. Now we have minimal national standards, MINAS, for industries. So these are for industries. So CPCB lays down specific standards for effluents, discharge from the industries, standard laid down for treated effluents are within the techno-economic capability of that particular industry for taking anti-pollution measures. Under no circumstances, Minas can be relaxed as because the same is techno-economically acceptable by the industry. And industries have already accepted to reduce the pollution level till the the industries have already agreed to reduce or to reduce the pollution level till the defined till the agreement. So SPCB can prescribe standards stricter than Minas. So SPCB has power to make these Minas standards more stricter, but they can't be relaxed. Now we will understand what is environment impact assessment. So it is a tool to assess the environmental compatibility of the project. So in terms of location, suitability of technology, efficiency in resource utilization. So the thing is that we will check whether the project location will have some environmental issues nearby that area, the technology we are using is suitable or not, efficiency of energy and efficiency in resource utilization. So how much efficient we are in utilizing the resource, and it provides conceptual framework for extending the cumulative assessment of development policies, plan and projects on a regional basis. A major instrument in and it is a major instrument in decision making. Means if EIA report says that this project is not suitable for environment, that project will not proceed further. EIA has now been made a prerequisite for the setting up of a new project and renewal of licenses of old and existing plants. Now now we will study monitoring of water quality. So why to measure water or wastewater quality? That we discussed earlier also. To assess present water or wastewater quality before treatment. Before treatment, we want to know what is the quality of water, because if we don't know how is the quality, how will we treat? So we should know what is the present quality of water or wastewater. And second is, if you want to design the treatment facility, so we should know what is the desired quality and what is the present quality of water. So based on that, we will decide which treatment unit to be used. So choice of unit. So based on the difference of the present water quality and desired water quality, this difference will tell us that what type of unit we need to use and how much big, and that unit will be how much big, means how much big unit it should be and how many units we have to install to remove the pollutant, and how much land area we require, and efficiency how much efficiency we should have for each unit. And so monitoring of water quality, so apart from that, we need to check whether the treatment units are working efficiently or not. So for that also we need to check the water quality and identifying the present and future problems. So present and future problems. So how will we do? So the water quality is checked or assessed round the clock throughout the year, will give us the seasonal variation. So based on these variations, we can see the trends, like how the pollutant is increasing, decreasing, or what is the change in the concentration of the pollutant with respect to time. It will tell us the future problems, so that we can plan accordingly which treatment unit to be installed further. So here are constituent of concern in water or wastewater. So in water or wastewater, suspended solid is one of the major constituent. Like we can see the solids which are suspended in water or wastewater. So they will cause sludge or sediment deposits, and if they deposit, they will create anaerobic conditions, and that will produce gases, odors, etc., and many problems. And apart from that, this is suspended solid. We have biodegradable organics in the water or wastewater. So they will cause depletion of oxygen, and they will cause microorganisms, because if organics are present and they are biodegradable, then microorganisms will automatically come and they will deplete the oxygen also. They are made of carbohydrates, fat, and proteins. So they will also consume BOD, COD, and they will consume oxygen. So they will exert some oxygen demand that can be measured as BOD or COD. And TOC, as they are made of carbon-carbon bond, so we can get some TOC also for these organics. In water, we have some pathogens also. They will cause some disease. They may cause diseases also. Nutrients also. Major nutrients are nitrogen, phosphorus are principal limiting nutrients for growth. And excess of these nutrients will cause eutrophication, lakes and ponds. So what we see, if a water body has excess nitrogen and phosphorus, it will cause excess growth of algae and aquatic plants. Because of that, sunlight cannot penetrate into the water, and it will affect the life of fish. So it is a problem in aquatic ecosystem, this eutrophication. Constituent of concern in water or wastewater. Yeah, this is actually continuation of this. So heavy metals, and these are generated from industrial activity. Some are toxic at small concentration. Heavy metals are all heavy metals are toxic actually. They are generated from industrial activity. There are some priority pollutants also, like organic and inorganic. They can cause carcinogenicity, muta, mutagenicity, and teratogenicity. So this is ability to cause defects in a developing fetus, and it can cause acute toxicity. And now there are some refractory organics. So these are surfactants, phenols, and pesticides. So they resist conventional method of wastewater treatment. Means these organics cannot be treated via conventional method of treatment. So they need some advanced processes for treatment. And there are inorganics also, like calcium, sodium sulfate added as water use. So when we use water and the water is discharged as wastewater, So we can find these inorganics there. Now we will understand water quality parameters. So we have physical, chemical, biological, and uh, bacteriological water quality parameters. So these are physical water quality parameters. So first one is suspended solids. Remember, the physical water quality parameter is suspended solid, not solids. Solids will contain dissolved solids and suspended solids. So here we will in physical water quality parameter we will study only suspended solids. So do you have any doubt till now? Hi, do you have any doubt till now? You can ask. You can ask in the chat box also if you have. Okay, we will continue. So the first physical water quality parameter is suspended solid. Suspended solid. So the wastewater contains a variety of contains the variety of solid particles varying from rags to colloidal particles. So rags are floating uh, floating solids which in wastewater they are very big in size to very small colloidal particles. So the solids can be classified into various categories depending upon the size of the particles. We can see here. So the size is if the size is less than 10 to the power minus 6 millimeter, then we call it dissolved solid. And if the size is more than 10 to the power minus 3 millimeter, then we call it suspended or non-filterable solid. And the range between 10 to the power minus 6 to 10 to the power minus 3 is colloidal solid. So this total range is for solid. We are concerned here in physical water quality, we are concerned about suspended solids. So we will consider this part. So here we will see one question. So suspended solid, it is related to suspended solid. So here what is given, I will read. Determining the concentration of suspended solids. A filterable residue analysis is run on a sample of water as follows. Prior to filtering, the crucible and filter pad are kept overnight in drying oven, cooled, and their mass of air determined to be 54.352 gram. So the plus crucible plus filter pad, its weight is 54.352 grams, and 250 milliliter of sample is drawn through a filter pad contained in porous bottom crucible. So from this filter pad, 250 milliliter of wastewater was passed, and suspended solids will be retained on that filter filter pad on the top of that, not from bottom. So what is question saying now? The crucible and filter pad are then placed in a drying oven oven at 104 degrees Celsius and dried until a constant mass of 54.389 gram is reached. Determine the suspended solids concentration of sample. So the crucible and filter pad weight was 54.352 gram, and then crucible plus filter pad plus suspended solid, which is the when wastewater was passed through that filter, suspended solids will retain over the filter, and then it will be kept in oven and for 24 hours at 104 degrees Celsius. Then its weight is weighed around 54.389 grams. So now what we have to calculate? We have to find suspended solids concentration. So first we will find suspended solids. Suspended solids will be 54.389 minus 54.352 grams. So the concentration will be, suspended solids will be 54 389 54.389 and 30. Check whether the calculation is correct or not. So this much gram, or we can say 37 milligram. Check whether it is correct or not. Then what will we do? We have to find the concentration. So concentration is generally expressed in terms of milligram per liter. So weight of solid in liter of water. 1 liter of water or wastewater. So what do we do for finding the concentration? We have 37 milligram of solid in 250 ml of wastewater or water. So we will convert the units, milliliter into liter. It will be 1000 milliliter per 1 liter. For water it is like that. So it will be into 4. So the concentration will be 148 milligram per liter. This is the answer. Now second water quality parameter is turbidity. So let's see what are the sources. Sources are same as suspended solids. Like sources can be from industries, sewage, from households, industry sewage from household, from industry, and these can be either inorganic, organic also. Inorganic part will be can be clay, silt, soil constituent, organic constituent can be plant fibers, plant fibers, biological solids, and most importantly, organic organics or organic compound from industries. So here we studied about source. Now we will understand about what are the impacts. So impact is that the turbid water is objectionable and it is not aesthetically displeasing. And it is aesthetically displeasing, not pleasing. And apart from that, that water contains small colloidal particles. So it can provide absorption site for chemicals and and microorganisms. Means chemicals and microorganisms can be adsorbed over colloidal solids. So what will happen? It will affect the treatment process. Means if colloidal particles are present, they will affect the treatment process. And if they will affect the treatment process, our efficiency will reduce. So that's why we have to remove. And we can remove these colloidal particles via coagulation, flocculation, and sedimentation. And apart from that, impacts are these biological. Uh, these are if they bio if they degrade biologically, they will their products are objectionable. And if they degrade biologically, means microorganisms are involved, and these microorganisms can cause disease diseases. So these are the impacts of turbidity. So now come to the measurement part. So turbidity is the measure of the extent to which light is scattered or absorbed. It is a measure of extent to which the light is scattered or absorbed. So, if you have seen any turbid water sample, it has some colloidal particles. If you send a beam of light, so that it will scatter, it will not go straight. So, for pure water without any colloidal particles, pure water without any colloidal particles, it will go straight. So, some part will be absorbed and some part which is scattered. So, for measuring the turbidity, we will scatter the beam of light and we will collect those light waves and you will check how much actually photodiodes are used here. So we will check how much difference, how much is the intensity of light which is uh, getting collected in uh, this collector, and based on that we will tell how much is the turbidity of water. So measurement is yeah this, and we have earlier we used to use Jackson turbidity meter. So what is this? Jackson turbidity meter. We have a jar and the bottom is glass which is transparent, and the jar is graduated, means it is calibrated. But how? So in bottom we had candle. So what we will do, we will fill the water and we will check the we will fill the water, we will check the turbidity. So how we will do, we will see new slide. New slide. This is the candle. So we will fill the water. We will first we will make a standard sample. Standard sample is made by silica. So first we will put 1 milligram per liter. We'll put 2 milligram per liter of silica. We will put it. We will fill it, and based on that we will calibrate it. So yeah, we will fill first we will fill the water sample, the standard sample, and by the time the flame ceases to be seen, the flame is not visible to us, we will mark that thing. So its calibration will start from this 0 and it will increase. Like I will give you one more example. If you fill it with distilled water, so you can see the light beam till the top, or it is not visible when you fill it till top. So then we can say its turbidity is 0, because if you can sorry, if you can see, the flame from top, you can say the turbidity is 0. Turbidity is 0 JTU, Jackson turbidity unit. And likewise, if water has some colloidal particles, so the water depth will keep on decreasing. So if it is less filled, then we can say it has more turbidity. More turbidity. And top, less turbidity. So this was about Jackson turbidity meter. Jackson turbidity meter. Likewise, we have nowadays electronic turbidity meters. Turbidity meters. So they work on two principles. One is adsorption principle and scattering principle. So we mostly use scattering principle, and we use formazine as standard. So when we use formazine as standard, the unit is called FTU. And in the scattering principle, what we will do, uh, this is the source of light. So this is the sample vial. This is the sample vial. It will pass through it, and you will measure the scattering at 90 degree. And if it is measured opposite to the light source, then it is called adsorption. So when formazine is used as a standard and light is measured in the scattering mode, so the unit is called NTU. At 90 degree we are measuring it, that is scattering. Adsorption principle, scattering. Okay. These are photometers. This is vial. This is electric bulb, standardized electric bulb. So use is Actually, turbidity is measured for clean waters, uh, not for wastewater. It is measured for treated wastewater. Now, third physical water quality parameter is temperature. So, the temperature is affected by ambient temperature. So, the temperature means temperature of water. So, it is affected by ambient temperature. It affects aquatic life, and shallow water bodies are more affected by temperature. If the depth of water body is small, then it is affected by the temperature compared to the larger depth water body. And the source is thermal power plants. Suppose thermal power plants use water for dissipation of heat, then it will cause increase in the temperature of water body. So it can be measured by ordinary thermometer, and it affects density, viscosity, vapor pressure, surface tension of water. So if it affects density and viscosity of water, then there may be little change in sedimentation. Because if you see in the sedimentation formula we will study later. In sedimentation, we study Stokes law. So Stokes law consists of density and viscosity, and if these two parameters will change, then the settling of particle will be affected. And this vapor pressure, if it will change, then actually in pipes for transporting water or wastewater we use pipes. So if vapor pressure reduces, then the gases dissolved will start to come out, and if gases will come out, it can affect the pipe material. And if surface tension of water is changed due to the temperature, then bubble formation is affected in aeration and other processes and dissolved air flotation. And temperature so affects the rate of chemical and biological processes. Yeah, if temperature will change, then these biological and chemical processes rate will change. It affects the rate of let's see. So it affects the rate of dissolution of solid, liquid, and gas in water. So if you try to add some chemical or liquid or gas, so if the temperature will affect the solubility of solid, liquid, and gas. So this thing is important because if we have to design the contact time or contact basins for disinfection and coagulation, so we need to take care of temperature difference or temperature variations. Sorry. So that's why it is important to check the solubility of solid, liquid, or gas in water. Now we will study about taste and odor. So taste and odor are imparted by gases. Gases like methane, H2S, CO2, and taste and odor can be imparted from dead or living microorganism. Mineral substance like organic and and inorganics industries, from industrial discharge. Organics, like organics, if organics are present, they will degrade and they will cause taste and odor problems. Inorganics like salts, like NaCl or dissolved metals, they will cause taste and odor. Now we'll understand what are the impacts. So first one is, it is displeasing aesthetically, not aesthetically, psychologically. It can cause psychological effect also, and it is displeasing. We will not drink the water which is which has taste and odor. And some odor producing organics can be carcinogenic. Measurement measurement is done by uh, adding the uh, sample, or measurement is done by diluting the sample to 200 ml volume and checking at wha- at which checking at which minimum dilution the smell is detectable. So what we will do, we will take the sample, let's say 1 ml sample, and we will add 199 ml distilled water and we will make it 200 ml jar. And we will check whether the smell will come or not. Smell is coming or not. Then we will add 2 ml plus 198 ml. We will again check 3 ml. Let's say at this dilution, at 4 ml of sample, the smell is detectable. So it is measured using threshold order number TON. It is A plus B by A. So A is the sample, B is the dilution water. So here it will be A plus B will be 200 and sample is 4 ml, so it will be 50. So TON here is 50. Now we have color. Color is aesthetically unacceptable and is not suitable for laundering, dyeing, and paper making, etc. So color can be reported as true color unit TCU. So first we need to know what is apparent or true color. So the apparent color is uh, when wastewater contains dissolved as well as suspended components, and true color is formed when suspended solids are removed. Then the color left due to dissolved solids is called as true color. Now sources of color. So the presence of organic matter in suspended solid, suspended dissolved colloidal form. So the presence of organic matter which can be in any of these three forms can cause color. And similarly, inorganic matter which can be present in suspended, dissolved and colloidal form can cause color. And these organic and inorganic matter uh, can be discharged through industries. So these industries can cause colored water, like dyeing industry. Uh, so they will impart color, and we'll see more sources. Dissolved organic matter like humus, peat, and tree leaves, and decaying plant matter, etc. They produce yellow or brown color. Some algae, they will produce green, reddish, or deep yellow waters. And soil runoff water, like the water will pass through soil, so different colors of soil are present, so they will produce yellow, red, brown, and gray color water. How to measure the color? So the method involves comparison of standardized color materials. Standardized colored materials are most often used. So we will take a standard and we will compare that standard with our test sample or wastewater sample. So how it is done? So color comparison tubes containing series of standard may be used for direct comparison of water samples that have been filtered to remove the apparent color. So first we will use, so to measure the color, first we have to remove the suspended solids, and then the true color will be visible to us, true color for wastewater sample. And we will make series of standards. We will increase or decrease the concentration. So we will increase or decrease, this arrow shows that concentration is increasing, and we will check whether the color is matching with A, B, C, D. So we will check whether the X sample is X sample has color similar to A, B, C, D. So likewise we will, so suppose it has 3 milligram per liter. Suppose the standard sample has 3 milligram per liter of color, let's say TCU. So we will say the wastewater sample has 3 milliliter per gram of has 3 milligram per liter TCU. So that 3 milligram which we are talking about, that is the result. So the result is expressed in terms of true color units. So that unit describes 1 unit of equivalent to color produced by 1 milligram of platinum in the form of chloroplatinate ion. So if you take 1 milligram of platinum in the form of chloroplatinate ion in 1 liter, so will it will be called as true color unit. So that is so it has one limitation, that that for it is used only for yellowish brown water. It is not used for other waters. So for colors other than yellowish brown, we will use spectrophotometric techniques. Now, sixth water quality parameter is specific conductivity of water. So what water, if water is distilled, it won't conduct any electricity. But if it will contain some ions, it will conduct electricity. And these ions are nothing but inorganic inorganic dissolved solids. So if we measure, if conductivity is more, we can say more ions are present, and if more ions are present, we can say inorganic dissolved solids are present. Inorganic dissolved solids. So we can relate it like inorganic dissolved solids directly proportional to specific conductivity of water. So TDS is, we need to understand what is TDS. TDS is total dissolved solids. So these are inorganic dissolved solids plus organic dissolved solids. So the water which contains less organic dissolved solids. So we can directly say, so if this is less, we can say TDS is equal to inorganic dissolved solids. So we can relate TDS like 0.55 to 0.7. It is proportionality constant into electric conductivity. Its unit is micromole per centimeter, and the TDS value which we will get will be in milligram per liter, and this value will depend on type of salt present in wastewater or water. And one more thing, this TDS is not measured in wastewater, which consists of more organic dissolved solids. So TDS is can be measured for treated wastewaters. Now we have chemical water quality parameters. So our first water quality parameter is pH. pH can be defined as negative logarithm of hydrogen ion activity. So negative logarithm of hydrogen ion activity. So the water contains it will water will dissociate into OH minus and H plus ion. So negative logarithm of this hydrogen ion activity is called as pH. So activity is denoted by this symbol, and concentration is denoted by this symbol. So if more ions are present in water, let's say more ions are present, multiple ions are present in water, then the effect of a single ion will be reduced. So the effectiveness of that ion is uh, is defined by activity. If multiple ions are present in water or wastewater, then the effectiveness is reduced, and that effectiveness is denoted by activity. And if the water has very less ions, and in that case, the effectiveness will not be reduced. So in that case, we will say activity is equal to concentration. So we can say activity is equals to concentration when solution is dilute. For dilute solutions, we can write negative log of H plus ion concentration. So this is pH. So pH will tell us whether the water is acidic or basic, and pH change can be due to industrial wastewater discharge, and you will see few more points. So pH affects metal association, pH affects the concentration of gases in water, pH affects the concentration of gases in water, and these gases, if they are present, they can also change pH. So it's a two-way relationship. So now we have second water quality parameter, that is solids. So solids are earlier we studied about suspended solids. These are this suspended solid is physical water quality parameter. But here we will talk about total solids and what are all the components. So let's study this thing in detail. So this is the water sample. So this contains all variety of solids, suspended solids and dissolved solids. So we will put that, we will evaporate the water at 105 degrees Celsius. For 24 hours we will get total solids. After that, these total solids are uh, are kept in muffle furnace. So at this temperature, what will happen? That organic solids or volatile solids will volatilize, and only fixed solids will remain. So the difference of now, if we subtract total solids with fixed solids, we will get volatile solids. So till now we understood about total solids, and if we come and if we heat the total solids, you will get no, sorry. If we heat the sample, we will get total solids, and if we will heat the water sample, heat the total solids at 500 plus minus 50 degrees Celsius, you will get fixed solids, and the difference of total solids and fixed solids will give us volatile solids. We understood these two things. And if we take this sample, we will filter it and we will get two fractions. One is the filter rate. The wastewater which will pass through the filter is called filtrate, and the residue left over the filter paper are suspended solids. So we will get so we will dry the filter paper. We will keep it in oven at 105 degrees Celsius for 24 hours, and that filtrate also. So we will get total suspended solids, total dissolved solids. The thing is that the filtrate, the wastewater which will pass through the filter will contain dissolved solids, and the wastewater and the solids which are retained on the filter paper will be suspended solids. So we will get total suspended solids and total dissolved solids. So likewise, similarly, we will do for total suspended solids, we will heat those solids to 500 degrees Celsius, and you will get fixed suspended solids. And likewise, volatile suspended solids can be calculated as total suspended solids minus fixed suspended solids. This is one thing. And likewise, if we will heat total dissolved solids at 500 degrees Celsius, yeah, the temperature is around 500 to 500 plus minus 50 degrees Celsius for around 2 to 3 hours. We will get fixed dissolved solids. Likewise, volatile dissolved solids can be calculated as total suspended solids minus fixed dissolved solids. Likewise, we can calculate the solids. Now we have covered two chemical water quality parameters, solids. Now we will learn about some ions. So water has major ions and minor ions. We are talking about natural water. Calcium, magnesium, sodium, bicarbonate, sulfate, chloride. These are major ions. Minor ions are potassium, iron, manganese, nitrate, phosphate. These are minor ions. And for these ions, we have to do the ion balance. So if ions are present, so what according to electroneutrality according to electroneutrality principle, electroneutrality principle, the summation of positive ions should be equal to summation of negative ions. So, but when we measure positive ions and negative ions, because of measurement, because the measurement is not accurate every time, so there can be small error. So that error, so we will that uh, balancing error should be less than 5%. So we will see the formula of balancing error. Summation of cation minus summation of anion by summation of cation plus summation of Ni into 100. So this value should be less than 5%. Then we can say our analysis of measurement of positive ions and negative ions is correct. And if it is less than 5%, we cannot say that our analysis is 100% correct, because this value can come because of more than one errors also. If there are more than one error, then also this value can come less than 5%. Suppose we made a mistake in measuring positive ions and we made some mistake in measuring the negative ions, and the error will be deducted. Then we can say like, no, this is, then also it can cause error. Now we have third water quality parameter is hardness. So what is hardness? Hardness is due to, many students are there. Okay, I will continue. So hardness is due to the presence of multivalent cation. Presence of multivalent cations like calcium, magnesium, aluminium. Can sodium impart hardness? Can potassium impart hardness? No, these are not multivalent cations, so they will not impart any hardness. So when they are associated with CO3, HCO3, then it is called carbonate hardness. When they are associated with chloride, sulfate, and nitrate, then it is called non-carbonate hardness. Non-carbonate hardness is also called permanent hardness. And carbonate hardness is called temporary hardness. The temporary hardness is removed by boiling. So, so that's why it is called temporary hardness. If you will boil, the precipitate will form and the hardness will be removed in the form of precipitate. And we will understand the treatment of hardness or removal of hardness in further lectures. So now we'll understand what are the sources. The sources are actually industrial discharge. And natural water may also contain some hardness, like underground water from wells and all. We, they are hard, and its impact is they consume more soap. More soap is consumed, more laundry expenses. They cause scaling in pipes. So it's a very big issue actually. For entire sewage treatment facility, the pipes contain 70% of the cost. So if the pipes are affected, then for replacement we again have to spend a more amount of money. So the pipes cost is more in the treatment facility, so it's a big concern. And apart from that, it can affect the taste of water. Now we'll understand how to measure hardness. So it is measured by titration method. So what we will do, the wastewater containing calcium, magnesium, or let's say hardness, wastewater containing hardness, calcium, magnesium, and other multivalent cations. We will take the water sample. We will add, yeah, we will add EBT as indicator, and we will add an uh, EDT as titrant. So let's understand the reaction first. So we will add EBT as indicator in the water, and the water will and water consists of calcium and magnesium ions. So it will react. EBT will react with these ions, and it will form EBT calcium magnesium complex. This complex color is wine red. So when we are adding the indicator, then the solution of color will change to wine red. And after that we will titrate. So when we'll titrate, this EBT complex will react with. So when we are titrating with EDTA, so it will cause displacement reaction. So the EDTA will replace EBT, and it will form EDT calcium complex or magnesium complex. And and EBT. EBT is eriochrome black tea. So this will have no color. It is colorless. So EDTA makes or forms complex with calcium and magnesium, and so it is colorless. And EBT color is its name is itself eriochrome black tea. So it will impart blue or black color. So this is the end point of the titration. Two reactions are taking place in this eriochrome black tea. So this is the end point. So at the end, we can see blue or black color, dark blue color. So the amount of this titrant consumed will give us the value of hardness present. When we will understand about the Mill equivalents and all, then I will tell the how to calculate it. Now we have fourth water quality. Now we have sodium. So sodium is abundantly present in earth. So all natural water contain sodium. Basically the seawater contains sodium, and If water, or we can say natural water, has more amount of sodium, then we can say it is polluted by either sewage or industrial wastewater. Sodium is actually non-toxic, but in large concentration, it can affect kidney patients. Now we have another water quality parameter, nitrogen. So if nitrogen is present in water or wastewater, in water, and we can say it indicates, indirectly indicates pollution, either by sewage or by industrial discharge. So in water, the four forms of nitrogen are present. One is ammonia nitrogen. It tells ammonia nitrogen, or it is called as free ammonia. It tells it tells that the water is recently polluted. And another form is organic nitrogen. So if organic nitrogen is present, we can say it tells the presence of complex organic matter in water. Another form of nitrogen is nitrite, NO2 minus. It tells, so first of all, it is very highly dangerous, and it tells partially decomposed, partially decomposed organic matter, and its limit is 0 milligram per liter for drinking water. And the fourth form of nitrogen is nitrate, denoted by NO3 minus. It tells, if nitrate is present in water, it tells fully decomposed organic matter. So these free ammonia plus organic ammonia, organic nitrogen, together called as total Jaldal nitrogen. So ammonia or ammonium This UV method, it can be measured by UV method, and nitrite and nitrate can be measured by spectrophotometric method. Another water quality parameter is chloride. So if sodium is present in water than chloride, there are more chances that chloride is also present. So if chloride is present, it tells the water is contaminated with sewage. So we will see how to measure uh, the chloride content. So chloride is nothing but Cl minus ion, and Cl2 is chlorine. So for measurement, we take the water sample consists of chloride ions. We use So here what we use titrant as silver nitrate, AgNO3, and we use indicator as potassium chromate. So what happens? So we will put the indicator, but what happens? The silver nitrate reacts with chloride ion and forms AgCl, which is white precipitate. So we keep on titrating the water with AgNO3, and AgCl will form, it will be white in color. And when all chloride is consumed by AgNO3, then this AgNO3 will now react with indicator K2CrO4, and then it will form Ag2CrO4, and it will be reddish brown in color. So this will tell the end point of the titration. So when the titration is complete, we will measure the amount of titrant consumed. Pen is not working actually. So we will measure the amount of titrant consumed, and the amount of titrant consumed, we know the normality of this solution, and we will multiply the normality with volume. So we know the equivalent of titrant consumed, and that equivalent we will relate, and that equivalent will be we know that equivalent will be equal to the chloride content. So that's how we will define the chloride content, and all the volumetric and all the titrimetric procedures. So my pen is not working. Uh, Now we have one more water quality parameter, that is chemical water quality parameter, fluoride. So found in fluoride is generally found in groundwaters, and fluoride for children's, fluoride is required in water because it helps in making the enamel strong. It combines with tooth enamel and makes it strong. So that's why the fluoride is required. Uh, the acceptable limit is 1 milligram per liter. So if the fluoride is required for the teeth health, and if the fluoride concentration will be more than 1, if the fluoride concentration is more than 1.5 milligram per liter, it can cause decoloration of teeth. So up to a limit, it is beneficial for teeth, but if it is more than 1.5 milligram per liter, it will cause decoloration of teeth and mottling of teeth. And if the concentration goes beyond 5 milligram per liter, it will cause deformation of bones. That is called bone fluorosis. So it can be measured by colorimetric methods, in which a standard sample is prepared and the color is measured using UV or spectrophotometer. So this is all about first lecture. Thank you.